Hello everyone, welcome to our channel techlteworld. So today we are going to discuss about the topic MIB, that is Master Information Block. Okay, that we are going to discuss for the LT today, and in coming videos we will prepare for the 5G also. But let's focus on the LT first. Once this LT will be covered, maximum of the information you will get, and there will be a slight change in the 5G and all. So when we talk about this master information block, so what exactly? There are few things that we'll discuss. What's the direction of this MIB? Okay, so when we talk about the direction of the MIB, okay, it will be from the eNodeB to UV side. Okay, and there are few more points that we will discuss. We'll talk about the SRBs. Okay, in the previous videos we have the SRB and DRBs videos. So this is signaling radio beer. So which SRB is going to be used for the MIB? As we know, there are three SRBs: SRB 0, 1 and 2 for LT. And if you talk about the 5G, one more SRB will be there, that is third. So in this case, basically none of the SRB is going to be used. Okay, and when you talk about which RLC mode is going to be used for this MIB, as you know, we have videos for this RLC mode also. So there are three modes: AM mode, TM mode, and UM mode. So in case of MIB, we are going to use TM mode. Okay, and let's talk about the channels. So how exactly it is going to use? So for logical channel, it will be going to use BCCH. For transport channel, BCH, and physical channel, it is going to use PBCH. Okay, now the question comes, okay, how many resource block is required? So resource block, how many resource block is required? Like in PSS and SSS, we know there are 6 PRVs are being required to decode. Okay, for the MIB also we will be requiring 6 PRVs. Okay, and let's talk about the position. So in a resource gate, what's exactly the position of MIB? So when you talk about the position, it is first subframe, second time slot, first 4 OFDM symbols, that is 0, 1, 2 and 3. I will show you on the grids also in next slide. Okay, so let's talk about the points basically, which is for the MIB. So these are the points. Okay, now which modulation technique is going to be used in this? That is QPSK. Okay, you know there are other modulation schemes are there. We'll talk about like the examples like QPSK, 16 QAM, 64 QAM. Okay, now 256 QAM. Okay, so these are the modulation schemes. Okay, we will have the separate video on this about the modulation. But yeah, and for the MIB, let's focus on this. So QPSK is going to be used. So periodicity, I have already. Now let's talk about the periodicity. Okay, like in PSS and SSS also we have the video for the UV power. In that you can see the PSS and SSS periodicity. That periodicity was 5 millisecond. Okay, PSS 5 millisecond, SSS 5 millisecond in a resource grid. But when you talk about the MIB, the periodicity of the MIB is 40 millisecond. 40 millisecond, if we talk about, means 4 radio frames, because each radio frame is of 10 millisecond. So after every 4 radio frame, you will get the original MIB information. Okay, and already we know that like MIB information is generated at every 40 millisecond, or you can say every 4 frame that I was discussing, 4 radio frame. okay, that is 10 millisecond of each, okay. And this and it is sent to the physical layer for the encoding, that encoding process and all we will see, okay. And then the physical layer will transmit it by in every 10 millisecond, that we call it as a PBCH decoding, okay. So in every radio frame PBCH will be get decoded, okay. And MIB, now the MIB payload, we are talking about that MIB size or MIB information, okay. That is of 24 bit. So that information is of 24 bits of information, that MIB, okay. And this MIB is received from the upper layer to the physical layer, okay. So this MIB is consisting of 24 bit, okay. So means the eyes, all the eyes. So this will be consisting of 3 bit of system frame number, 3 bit of PH information, okay. So we'll talk on this, okay, on the next slide. So these are basically the introduction of the MIB, that what exactly it consists of. Let's go through slide by slide, okay. So yeah, this is the slide which I have put for more visibility, okay. So like MIB, we have already discussed, it's a master information block. Periodicity is 40 millisecond at RRC, 10 millisecond at 5. Okay, location we have already discussed, like it is on a first subframe. If you see, this is one radio frame, okay, of 10 millisecond, okay. And if you see, this is one subframe, 2, 3, like that, okay. So if we'll talk about the MIB position, so it's first subframe, okay, first subframe. This is first time slot, this is second time slot. So this is on the second time slot, okay. And the first four OFDM symbol 0, 1, 2, 3. So this blue portion is basically that four symbols, okay. This is where your PBCH is going to be decoded, and this is how the mapping channels for the MIB. Okay, so in logical channel you can see this BCCH, then it is further mapped to the transport channel on the BCH, and then finally it is mapped to the PBCH, which I am showing the resource grid. So in 10 milliseconds, so in one radio frame, it will be decoding that PBCH info. Consecutive 4 radio frame, 10, 10, 10, 10, that will be 40 millisecond, and after that 40 millisecond, we will get the original MIB. I have the figure for that. Okay, the channel that is being used is PBCH and the information element. Okay, so what are the information elements basically MIB consist of? Okay, so MIB consists of system frame number, number of TX antenna, bandwidth, pH information, and the physical cell ID. Okay, so we'll talk about each little bit. Number of TX antenna means it can be 2 cross 2, okay, 4 cross 4. So you can see with the logs, it's 2, it is written, it can be 4 also, okay, based on the number of transmitting antenna. Okay, when we're talking about the bandwidth, you can see here 10 megahertz. Okay, so we know, I think we have that video for that. So when we talk about the bandwidth, okay, it can be 5, 10, 15, 20, 25, you know this, okay. So this what exactly this bandwidth we are talking about, okay. So this information element, this information will also get in the this MIB block. And
Yeah, and we talk about the SFN. So SFN is nothing but the system frame number. So let me give you a little bit small information on that. So this system information is nothing, but it will give you that, okay, which radio frame actually we are talking about. Okay, so this is something like it is a count, it is counting, okay, the arm kind of thing, which is tickling in every 10 millisecond, okay. And when it tickles, okay, so it will jump to the other number, okay. So in this case, like if you talk about the range of SFN, it is 0 to 1023. Okay, total you can tell it as a 1024 as a count. Okay, total SFN. So I was telling that tickling in every 10 millisecond. Okay, so it will be tickled in this particular number. Okay, and when we talk about that is the system frame number, and when we talk about subframe number will be tickle, or it will be in between 0 to 9. So 0, 1, 2, 3 up to 9. Once this subframe number, so subframe number, if you'll talk about the tickling time of subframe. Okay, so subframe number will be of 1 ms of tickling. Okay, so it will tickle 0 to 9, and then once it will reach to the maximum value. Okay, so for subframe number 9 will be the maximum value from 0 to 9. Once it will reach 9, then it will, what you can say, it will goes back to the zero, or the sfn get increased by one. Or in simple language, suppose we are at sfn number 10. Okay, so after when you are in 10, the subframe number count tickling will be there. Okay, from 0 to 0, 1, 2, 3 up to 9, and then it tickle to the next number. So it will tickle from 10 to 11. Okay, this is what exactly the subframe number, the subframe number will do. Okay, and system frame number is 0 to 1023. So it will tickle in every 10 millisecond to 0 to 1, 1 to up to till 1023. And once it will reach to the maximum, then it will again tickle back, and it will go to 0 as a counting. Okay, this is what exactly the subframe number concept is. Okay, so it will giving you a new number. Okay, which subframe is being used. So I have already mentioned 0 to 1023. It is a 8 bits of information. Okay, so what can be the maximum size, or what can be the maximum value? In this case, 8 bit of information, 8 bit of information with the maximum 8 bit of information can be this one. Okay, 8 bit means 1 octet. Okay, and if you convert it into the decimal, it will come around 255. Okay, this is what exactly the sfn is. I think this much information here is enough to go. Okay, so I hope you understand the concept of sfn. Number of tx antenna we have already mentioned. Bandwidth, it's a 5 megahertz, 10 megahertz, 15 megahertz. Which bandwidth we are that it's being used, that it will give the information. So now when we are talking about the ph information, I can give you a little bit brief. Like in this, we will be using uh, 1 bit of normal or extended ph, and 2 bit of ph ng value. So I will talk about these terms. Okay, in this, that what exactly it is. Okay, and I have already mentioned this is 24-bit of information. When we'll go in a logs, let me check I have put or not. Yeah, so this is what. So as per the spec number 36.331. Okay, so this basically we are talking about in the previous slide. Okay, this is how exactly the DL bandwidth. Okay, so it can be like this is showing an RB number, that is resource block. If you're talking about the resource block 100 RBs, it means it is 20 megahertz. Okay, I think you must aware of this. Okay, and in ph configuration we'll get the ph configuration information. Okay, and system frame number I have already told you, it's 8 bit of information, 8 bit. And there will be the spare size. So when we talk about the above information is of 24 bits, it means in this the system bandwidth will be having carrying 3 bit of information. PH will be carrying 3 bit of information, in which 1 bit will be the normal or the extended PH, or 2 bit will be the PH NG value. Okay, and your system frame number will be using 8 bit of information, and we will be left with 10 bit, and that 10 bit has been reserved for the future use. Okay, so there are the few terms which is being used constantly, or which is going to be used about the channels. Okay, so I think you can refer the channel video and all. Okay, but let me give the one liner for this. Like PBCH, when we are talking about the PBCH, it is nothing but the physical broadcast channel. Okay, and this channel basically carries the all cell specific information. This is what in one liner you can say the PBCH is. You can refer to the previous videos. Okay, and when in this we are going to use the word PCFICH. So PCFICH is nothing but the physical control format indicator. Okay, so this contains the information about, okay, the number of OFDM symbol that are going to be used for the PDCCH in the subframe. Okay, So PDCCH, what exactly that? So when we're talking about the PDCCH, it is nothing but the physical downlink control channel, and this channel contains the scheduling information what need to be scheduled. Okay, so this all the scheduling information will be with the PDCCH. Okay, now the PH which we have used here. So PH is nothing. It will be giving the information about, like it is by name. You can call it as a physical hybrid arc indicator channel. Okay, and this carries the information about the hybrid, that is hark, ACK or NAC. Okay, that is a separate topic, hark. So probably we have that video on the hark. Okay, you can refer that. Okay, so this is what exactly the PH is. Or if you can talk much more on the PH side, so PH, the you can say the location of PH, where exactly it will decode the PCFICH. Okay, so PCFICH you can already see it is a which exactly it will be showing about. It contains the information about the number of OFDM symbol. Okay, so PH will be the main thing, main element which is going to locate. Okay, now, PCFICH, I have already mentioned, I was already mentioning, so it carries the CFI information, okay, that is control format indicator. By name itself, you are able to see, and I have talked about one NG value, okay. NG value is not, in a simple word, the number of PH group which is going to be used by the first symbol. That is what exactly the NG. So if you talk about the, I will not go much more deeper. I will not make try to make the video much more complicated. Okay, so ng value is 1, 1 by 2, 1 by 6 and 2. These are basically the ng values. Okay, so we will discuss more on some other videos about this, but these are the one liner thing which I am telling you. So basically it is used at the starting of each 1 millisecond subframe. Okay, or you can say it can provide the information about the number of symbol used for the PDCC. This is what I have already mentioning about the PCPH. Okay, so that we can have the separate topic, but yeah, this much information is enough as of now. Okay, now, or if you'll see the PDCCH also I have mentioned, so I think PDCCH you will be having little bit information, but let me give you some brief before going further into the video. So PDCCH is a physical downlink control channel. Okay, the DCI information basically is carried by the PDCCH. Okay, it provides the information about the number of OFDM symbol that is going to be used by this PBCH. Okay, and the symbols I have already mentioned that it will always start from the each subframe. Okay, so these are basically the information about the PDCCH. Okay, so let's move to the topic further. Now the question come, okay, so how exactly the 24 bit of payload, that is MIB, okay, the original MIB payload is going to be processed. Okay, so these are the steps which I have already mentioned. Okay, so let's talk about this PBCS transmission. Okay, that how exactly by figure you can see it will go through the process of CRC attachment and then the convolution encoding and then the rate matching and then scrambling, then modulation will happen, then the layer mapping, and then finally resource mapping will be done. Okay, so let's talk about, so this 24 bit of information. Okay, the MIP payload, that is 24 bit we are talking about, which came from the higher layer, okay, to the physical layer. Okay, now the physical layer will do this processing. Okay, so you can see the CRC attachment. Okay, so CRC attachment before that. Okay, that CRC, what exactly is CRC? Okay, CRC is nothing, that is cyclic redundancy check. Okay, and you know that CRC is being used for the error detection in the transport block. In a simple line, we can say that is the CRC. Okay, so what we will do with this 24 bit of information, we will add 16 bit of CRC. Okay, so 16 bit of CRC is generated by the CRC module. Okay, and finally, and that will be scrambled over the antenna. Okay, by using some masking and all. Okay, So here you can see the 24 bit of information will be attached with the CRC attachment will be done with this. Okay, that is 16 bit of CRC will be attached. Now your information will become 40 bits. Okay, so you can see this 40 bit of size. Okay, it is converted after the CRC attachment. Okay, now the next process that is being performed over this 40 bit, that is convolution encoding. Okay, so what exactly the convolution encoding will do? A tail of a bit. Okay, uh, so it is performed over the 40 bit. Okay, so when we're going to perform the convolution encoding, so before that, first of all, know what exactly the encoder is. So encoder is nothing, it's a discrete linear, okay, time, you can say, it's a time variant system on that. Okay, so this convolution encoding, what it will do, it always used to create a three output or three streams, okay, of the same size. When you are whenever you perform the convolution encoding over any of the bits. Okay, so when we are performing the convolution encoding over this 40 bit, it will create a three bits of information, means every output will be it will form into the three streams, and each will be have their own function. So now 40 bit will be after convolution encoding. So 40 bit plus 40 bit plus 40 bit, it will become 120 bits of information. Okay, after convolution encoding, once the convolution encoding will be done, now there is other process that is rate matching. Okay, and that we are matching it by 16 times. Okay, so rate matching is nothing but the repetition of the coding. Okay, this coding by the number of times which we are mentioning. So here we are matching the rate with 16 time. Okay, so what it will do, it will repeat the code for the 16 time. Okay, and it will create the bits which will come if we'll go with the counting. So 120 bit into 16, it will come as a 1920 bits. So now after rate matching, which is going to use your turbo coding and all, and it will create. So in previous one, like three output which I was discussing about the convolution encoding. Okay, so 3 bit of information, 3 bit of a stream is created. Okay, systematic bit, and there are two other bits. Okay, so that we will cover on a separate topic when we are going to discuss much more deeper into the physical processing. Okay, this is also the physical layer processing anyhow, but yeah, that is a separate topic that we will discuss. So now after rate matching, it becomes 1920 bits of information. Now this 1920 bit will be scrambled. Okay, so if we talk about what exactly the scrambling is, so scrambling is nothing but removing all the sensitive data, okay, which cannot be, you can say, decoded by anyone. Okay, so it will be scrambled, okay, in a long sequence of 1920 bit. Okay, so that 1920 bit is scrambled and over the 1920 bit long sequence. Okay, and then further it is going to be get modulated. So modulation, everyone know, like in a carrier. Okay, suppose you have a carrier and original signal you are going to modulate over a carrier so that it can be transferred. Okay, so now I have already mentioned that MIB is going to use the QPSK. Correct, QPSK modulation. So here your QPSK modulation will be applied over 1920 bits. So if you are going to, and what exactly QPSK says? QPSK says 2 bits per symbol. Okay, so here is 1920 bits. So to 1920 bits, if we'll convert that, if we'll apply that, it will become, how much it will become? So by figure, or if you'll go whenever it is going to map with this, okay, now your 1920 will become, if you'll divide it, it will become 960 bits, correct? You can calculate it. Already mentioned this become 960 in a count, okay. So 960 symbols, okay, QPSK symbols, okay. Now this 960 QPSK symbol is now, we are going to do the layer mapping, okay. So all the QPSK symbol are mapped over the antenna ports, and that is further we will do the resource mapping over the grid, radio grid, okay. So now it will be mapped on the center 6 PRBs. I have already mentioned it is going to use the 6 PRB, so center 6 PRB. And where exactly it will be locating, it will be using first subframe, second time slot, first for OFDM symbol, correct? So now let's see how exactly this 960 uh, symbols, okay, or you can see this how exactly it is going to be transmitted, okay, or how exactly it is mapped, okay. So you can see when you're talking about the 960, now this 960 symbols, okay, so it will be, you can consider if you'll divide it, so like 240, 240, 240, and 240, okay. Further it is mapped, okay, in each frame radio frame. So each radio frame is of 10 millisecond, 10 millisecond, 10 millisecond, 10 millisecond. By the figure you can say it will become 40 millisecond, okay. And I have already mentioned after 40 millisecond your original meme will come, and further again for the four radio frames it will decode, and then again your original meme will come. This is how exactly your meme you are getting at the lower layer, okay. So now 960 symbols, you understand, 960 by 4 you can see it will come 240, 240, 240, 240, okay. This is how exactly it is mapped. And see, this is your one radio frame, it's an enlarged picture, okay. So one radio frame that is of 10 millisecond, and at first subframe, second time slot, first four OFDMS symbol is basically here exactly your PBCH is going to decode, okay. So this is 10 millisecond at file layer that we are talking about, okay. So after four radio frame, same radio frames, like one radio frame, so one radio frame, two radio frame, three radio frame, four radio frame, here PVCH is decoded, here PVCH is decoded, here it is decoded, here it is decoded, okay. So it is 10 millisecond, 10 millisecond, 10 millisecond, 10 millisecond, and totally you can say 40 millisecond. So after 40 millisecond, your original MIB is going to be decoded. And we have seen, if you reverse the process, okay, if you reverse this process, you are going to get that 20 bits of payload, okay, that is the original information of MIB, which is nothing but this information, okay. So this is what exactly about the MIB, okay. For the physical layer processing, I will have the separate video, okay. So thanks for watching this video. And if you have any correction or if any input need to be sent, okay, please write it on a comment, okay. And thanks for your support till now. We will come with the next set of video, probably it will be on SIP1 and SIP2. So just be in touch, okay. Thank you.